What's poppin', dogs? Mr. Allen here with a little volume and surface area optimization. So grab your TIs. This thing's about to get crazy, all right? We got the volume of an open top box. It's always an open top box. It could be a closed top box. We'll talk about that later. With a square base is 50 cubic feet. What dimensions of the box would minimize the amount of material being used? Interesting. So we're not asked to figure out the volume. We're given the volume. We're asked to figure out the dimensions that would minimize the amount of material. What's that mean? Well, my material is on the surface of this box. So essentially, I'm trying to figure out the surface area. I want the minimum amount of surface area with the volume of 50 cubic feet. So it's a square base, though. Square base. I'm going to label my base with X and X, okay? They're the same length, right? It's a square base. I know it looks like kind of like a rhombus, but it's three-dimensional. Hopefully it looks okay for you guys. It looks cool for me. And then I've got my height of the box, which I also don't know. I got to figure out these dimensions. So if I can get X and H, we're good to go. We've answered the question, right? What are the dimensions that would minimize the surface area is essentially what we've come up with. Well, how am I going to figure that out? Let's see here. Volume, I know the volume is length times width times height. And in this case, it's 50 equals, for this one, it's length times width times height. So really it's X squared times height, right? X squared is my length and my width, X times H. Cool. Okay, and then I got surface area, right? Well, surface area, I'll put that in a different color here. Surface area would be my base, which is X squared. And then I've got X by H for this side. I've got X by H for this side, that side, that side. I have four sides that are all X times H. So 4XH. And this is what I really want to optimize here. Right? I want to minimize it, rather. Okay? But I got X's and I've got H. So I want to have it in terms of one variable. I think what I want is the area, I'll just say area, as a function of X. That's what I really want here. Well, the X squared is good to go. But how about the 4XH? It's not good to go. But perhaps I could use this blue little equation I got over here and solve it pretty easily for H. I can divide this by X squared, and I've got H equals 50 over X squared. Can I substitute that in here for H? I absolutely can. I will have plus 4X, and then in parentheses, I'll have 50 over X squared. 50 over X squared. So I'm going into the quadrilateral, I'm going into the open top box there a little bit with my writing. But we have a nice, wonderful function right now that we can leave as is. You can also clean it up. Some teachers may want you to clean that up. I'll show you guys what I mean. So if I have area as a function of X now is X squared plus 4X times 50 over X squared. I could multiply the 4 and the 50, so I'd have A of X equals X squared. 4 times 50 is 200. And then the X over the X squared, that'll just reduce to X. So if it's a multiple choice question where they're asking you to write the function, this would probably be the answered choice. But if you're just mathing in your calculator, this is okay to plug in, okay? So let's go to our Y equals. We'll plug it in. I'll just plug this one because it's less typing, I guess. But I got X squared plus, and then I'll do a little fraction action. Alpha X is how I did that. 200 over X, and that's it. Cool. All right. I often like to just use this one because just in case I made some kind of a little error, but we should be good to go there. So this is a rational function because we have an X in the denominator there. So that's kind of interesting. Let's see here. To adjust this thing, it's a bit of guess and check, but you can, do an educated guess. I'm going to go to my window. I probably don't want 0 as a length, right? So it's 0 is as low as I would possibly go for a dimension of this base. And let's think about numbers that multiply to 50. What's 5 by 5 by 5? That's 125. What up, Jenny? Jenny wants to go back outside. We're gonna go outside after we finish this video. I promise you, okay? We're optimizing this open top box problem right now. It's crazy fun. We'll be right outside in a moment, okay? She said she's going to wait. All right. Anywho, So 5 by 5 by 5 would already be bigger than the 50 cubic feet. What if it was like 3 by 3 by 3? That's 27. So maybe somewhere in there. How about I go to an X max of 5 and see what happens, okay? Now, if I just hit graph, it's just going to adjust my X's, okay? And I might not see everything I want. It really depends on how you have yours set. Looks like mine's going up to 10 and negative 10. But check this out. If you adjust your X's like I did, okay, back to my window, my X's are 0 to 5. And then I hit zoom, and I go down to option 0, zoom fit. Okay, Mr. Ernst does not want you to know this. He hates zoom fit. Shh, don't tell him I told you. Okay, don't tell him I told you. So zoom fit, or I can just hit zoom, and I can actually just hit the number 0 without even scrolling down. It'll adjust that stuff for me. Now it looks like perhaps I want to see a little bit further, even further to the right, so I can see this thing kind of go up. I have a feeling I know about how this is going to look. So let's do that. Let's adjust this. I'm going to go to like 15 now for this. Okay, and I'm going to go zoom 0 and see what it looks like. Ooh. Because I'm looking for a minimum, right? I'm looking for a minimum. So this thing should have kind of a dip there. This is enough to get it done. But I'm going to go even more though. Okay, I'm going to go to like 30 here. All right, and then I'll hit zoom 0 and then I can really see this. Oh, yes. Okay, now I can really see that dip. I'm trying to find that minimum right there, okay? So now we're ready to calculate. Cool? So what I had at the end there was 0 to 30. You didn't have to do that. Could have been some other options. But that zoom 0, the zoom fit, zoom 0, dials in the Y's for you after you educatedly guessed for your X's. Takes one of the dimensions out of it, which I find to be very helpful. All right, so now we're going to hit second and then trace to get my minimum for this one. All right, or you can just hit the number 3, or you can hit enter. Okay. And then my enter button and my second trace is not working right now on this to that. It's an emulator thing. I don't know. But anyways, I'm working around it, okay? So if I hit enter now on my left bound, and then I arrow over to my right bound, somewhere to the right of my minimum, and I hit enter one more time, boom, we've got a minimum of 4.6415. So that's my X value here, people. My X value is X equals 4.6415, so on and so forth. Okay. Cool. Now, you can either use these values, depending on what your teacher says, or you can store this value. All right, that's an option as well. If they ask you what is the surface area, it's 64.63 square feet. Okay, my Y value is my area, my output. Okay, but my X value is 4.641. So right now I have, we'll go 2 decimal places, 4.64 feet. That's 1 tick mark by 4.64 feet. That's 1 tick mark for feet. By, I got to get my height now. How am I going to get my height? This guy right here. That guy right there, okay? Now, if you want to know how to store this thing, I'm going to hook it up, okay? Ready? Check this out. If I hit Alt or X and then I hit second store, sorry, hold up. Not second store. If I hit X and then store, it gives me that little arrow. I can hit alpha A and it will store that value as A. Look at that. Oh, that's the number we had, right? So now what I can do is I can do 50 divided by alpha A squared. Not totally necessary right now because we're not mathing too much with it, but kind of a nice little tip. If you ever want to store numbers that you found, intersection points, whatever, that's how you do it. X, store, choose your variable, okay? And then we'll hit enter. Boom, I get 2.32. So 2.32 feet. Did I answer my question that I wrote? What dimensions of the box would minimize the amount of material being used? That was the minimum surface area. That was my X value for the minimum surface area. It was 64 point something or other. Actually, I can bring that back up. Alpha Y. Enter. It was 64.633 was my surface area, my minimum surface area, given that volume and that it's a square base. If this were a closed top box, the only difference here, guys, is my surface area would be 2x squared. I'd have a top and a bottom. Everything else process-wise would be the same. I would just have to have a different window adjustment and whatnot. All right, so there we go, guys. Boom, dimensions that would minimize the amount of material used while having 50 cubic feet for my volume. Hope that helps you guys. And I don't know, that's a lot. They're kind of a beast, but you'll get there. If you have any questions, put them in the comments, find me in the halls, and have a great day.